have a skydiver. What do we know about the skydiver? He's falling. So that's all we know.
Yeah.
Don't know anything else. Okay, so he's falling. So what forces are acting on him if he's falling? Gravity. Gravity's pulling him down. So mg for gravity. I don't know what its m is, though, but I'll just leave that there for now. What else is acting on him?
Normal force.
Normal force would be if it was on a surface.
Air resistance.
So if air resistance pushing up. Sure. All right, air resistance. How much is the air resistance?
So half the weight of the skydiver.
Okay, so 1/2 mg is our force due to air resistance. And that's all we know. What do we want to find?
Air resistance is half.
Okay, so when this is the case, we want to know acceleration is that much. Keep that in mind. So we don't have enough to figure that out right now, but we use the process. First things first, free body diagram. We got that. What's our next step after that? But second step, we need that net force. All right, so we look at the forces that are acting on him now. If we call downward positive, because he's falling, it doesn't matter which way we do it, but I have one force pulling down, his weight, mg, plus another force, the air resistance. But the air resistance is going up. Would that be positive or negative?
Going down.
Exactly. It'd be negative. Because he's going downward, so it's working against him. So we have mg plus a negative half mg. What do we get? mg minus half mg. What are we left with? 1/2 mg. No numbers, but we do have the net force, or at least an expression for the net force. We do know it's half the weight that's acting on him, because the air resistance cancels out the other half. So if that's the second step and our free body diagram was the first step, the last step is to do what? So now acceleration is equal to the net force divided by the mass. Now we don't know what the numbers are, but let's plug in what we got. So we have half mg over m. But I have half mg divided by the mass. What can those masses do? Exactly, they cancel out. So these guys cancel out. We're left with A is 1/2 of, well, g. And what's g? Gravity, acceleration due to gravity. So if that's acceleration due to gravity, then acceleration is 1/2 of 9.8, or about 10 meters per second, which is 5 meters per second. So it doesn't even depend on how massive he is. It could be 1 kilogram, it could be 1,000. Once the air resistance is half the weight, he's accelerating at 5 meters per second.